In this video, we're gonna focus on advanced question on exponential function. We are given a question here. They said find dy dx if y is equal to exponential tan s. Of course, this is the first thing. This is the first thing you have to know here, that whenever you are given a question to find the dy dx or the derivatives or the differential coefficient of that function, the first thing to do is to identify the function. So when you look into this question here, that is y equal to exponential tan s, it means that this particular question here is an exponential function from the question point. From the question point here is an exponential function. All right, please don't be confused. So the question now is, how do we differentiate an exponential function? So if I have an exponential function here, the solution first, if I have an exponential function here, that is y is equal to exponential f of s. The dy ds of this, that is finding the derivative of this particular function here, will be equal to class differentiate what is at the top, and this will be f prime of s. All right, repeat the equation, which is going to be exponential f of s. So this f prime of s here represents the derivative of f of s. When you differentiate f of s, you get an expression like this. Please take note. So let's differentiate this here. We have this to be class y, the equation to be y is equal to exponential tan s. Our intention here is to find the dy dx of this particular function or this particular equation. Class, remember, the format is to differentiate what is at the top, take it down, and repeat the equation. So what is at the top is tan s. The question now is, how do we differentiate tan? Now, tan is a trigonometry function. Tan is a trigonometry function. So let's know how to differentiate trigonometry function for us to be able to differentiate this tan s here. Please take note. To differentiate trigonometry function, the first thing to do here is to learn or to understand special functions of trig and their derivatives. So what are the special functions of trig and their derivatives? Now let's look into the special functions of trigonometry and their derivatives. Okay, now I have this to be this is my line. This part here is for the function, this part here is for the derivative. So if I have a equation here as sine s, the derivative of sine s is cos s. Please take note of it. This is just a special function. That is, you don't need to prove it. You have to just know it. Okay. So the next is, if I have cos s, the derivative is minus sine s. Whenever you have c at the beginning of any trig, the result will always appear to be negative of. Please take note. Now the next is tan s. The derivative is sec square s. Okay, let's move to the next one here. The next is sec s. The derivative is sec s tan s. Now, what is the short way to understand this here? The short way to understand this is this. Whenever c is at the beginning of the letter, we say that the answer must have negative. Now, whenever c is at the end of the letter in any trig, it means combine. That is, you have to combine for sec here, you have to combine sec with anything, any function. When you differentiate that function, you have sec. What is that function? When you differentiate, you have sec is tan. So you combine that with tan, which is tan sec s tan s. So we have the next one here, cot. We have the next one here, cot s. Cot s is minus cos sec square theta. s. Sorry for that. Cot s is minus cos sec square s. Please take note. And we have the last one here, that is cos sec s. Remember, c at the beginning is negative. I will have this to be negative. C at the end means combine. So I will repeat cos sec s. Combine. What is that function? When you differentiate that function, you have cos sec is cot. So this will be cot s. So these are the two special functions of trigonometry and their derivatives. So if you are given a question and the question is on sine and you're asked to differentiate that, the answer will be cos. If you are given a question and the question is on tan, the answer will be sec square s. So class, we are not asked to find only sec square tan s. Let's go back to, we are not asked to find sine s, cos s, tan s, sec s, cot s, cosec s in the equation. We have a question there, and the question is given to us as y is equal to exponential tan s. And remember, the format here to differentiate exponential is to differentiate what is at the top of the exponential. You take it down and you repeat the equation. So our dy dx here, dy over the s of this here will be equal to class differentiate tan. What will be the answer? Sec square. So I will have sec square s. Repeat the equation. What is the answer? Exponential tan s. Class, this is my answer. Differentiate what is at the top here, you have this. Repeat the equation, you have exponential tan s. So the dy dx of exponential tan s is sec square s exponential tan s.